Hello from Houston. Welcome to Data Stewardship in an AI-driven ecosystem. I'm delighted to be speaking at Data Platform Summit 2020, and even though this session is virtual, I'm hoping to see you all at next year's event. So thank you for joining us today, and I'm looking forward to speaking to you on InterpretML, FairLearn, and what was formerly known as WhiteNoise, the new SmartNoise system. Thank you. I'd like to introduce myself, and I'm Alicia. I'm one of the Microsoft AI MVPs. I'm a member of PASS.org as well as the global AI community. Locally here, I do host the Global AI Bootcamp as well as the Global Azure Bootcamp, and those are both the Houston editions. So you may see me out and about and around the Houston MTC quite often. I love our community here, and there's just so many opportunities to grow and learn within the Microsoft community that I'm truly grateful to have an opportunity to contribute back. I've been in the data and AI space for over 10 years, probably closer to 14, and have a background in traditional data warehousing and analytics. I do hold certs in AWS and Azure, as well as Databricks partner certification. Thank you. It's great to meet everyone. So let's talk about responsible ML and why it's important. So one of the reasons why I truly enjoy working with Microsoft and working with Microsoft products is especially with AI, they have been front and center with respect to putting an emphasis on making sure that there are structures in place for us to use this technology responsibly. So when we're looking at building our machine learning modules, what we're doing is we're actually collecting the data and hoping that the system will automate and trigger actions for us so that we don't have to do as much work. The system doesn't have to do much work, and the work what we're classifying as work is really decision making. So just like with any employee, because now the system is an employee, we need to have a checks and balances system in place so that we can take a look on past performance and see if performance is in line with what the expectation is. And so when we look at some of these machine learning modules that we've been putting in place, and we're trying to make this determination that yes, this AI worker, this digital worker that we're building and that we're giving the authority to make decisions to is making the right decision, that's when it's really important for us to kind of start looking at our controls that we are integrating into our AI and machine learning modules. So one of the big questions that comes into play is, are we making fair decisions? And what kind of bias are we introducing to our digital worker? So a very common use case of this is credit card applications. If you were following the Oculus headset news alert, you'd know that there was a requirement to create a Facebook account so that you could use the Oculus headset. And many people who, for some reason, some back-end process started deactivating Facebook users who signed up more than once to go ahead and activate their Oculus headset. So the response was of course an automated response, and of course there was verbiage in it saying that there was a review by the organization prior to the account being activated. But the speed with which the decision was made, like, kind of made people think that, hey, this was probably some type of intelligent worker in place and some type of automated process. So when we have these types of decisions that are being made in bulk across huge sets of people, how do we go back and how do we say whether this was a fair decision? So that is one of our challenges when we're looking at machine learning projects. Another challenge that we face is the protection of the users whose data we are using to build and train our data models. Many of our projects contain information about either our customers or our employees or our vendors, and there are many data points that we pull out to identify a person's behavior and patterns that affects the outcome of our machine learning module. Now, what differential privacy lets us do is it helps us to extract those data sets and anonymize them so that we are not giving full data sets to our users, and users querying the data set have access to just enough of the data set to validate and or train their result sets without being able to reproduce the data set in its entirety. So an example of this would be if you did a select from one table in a database and received 5 fields about a user and performed an additional select against a second table that had the remaining 5 elements identifying a user, then you would be able to go ahead and piece those 2 queries together to comprise the entirety of the data set associated to that person and perform that identification. And differential privacy is a system that's going to go ahead and allow us to return smaller bits of data and make it harder for users to reproduce. The additional thing that responsible ML lets us do is it helps us document the machine learning lifecycle. Now, many of us who build models know that we have different versions and different data sets that contribute to the results and contribute to kind of like the accuracy and the predictions of our different models. And what responsible ML does is it's going to give us the actual extra layer of adding in that metadata so that we're able to kind of take that step back as far as stepping through what results were affected by what data sets and give us kind of a better ability to understand how we get to the results. So looking at these capabilities, I've picked out a couple of the top services that best help us to provide these additional layers. to help enable developers to implement and add responsible ML to their development and design process, Microsoft has put together quite a few packages with prepackaged code full of examples and samples to help us as developers to take learnings from bigger communities and kind of jumpstart that process of adding responsible ML to our machine learning projects. So the first one we're going to talk about today is InterpretML, and this will add that layer of explainability to our projects. The next one is going to be FairLearn, and this package will let us look at the fairness of our models and check to see what biases are occurring due to some of the variables that we're using out of our data set. And finally, I'd like to go over SmartNoise. And SmartNoise is what was formerly known as the WhiteNoise package. And this is that system that enables developers to maintain the safety and security of their data via differential privacy. So let's get started with FairLearn. So let's talk about the influence of unfairness and bias within AI systems. So when we're using these AI systems to facilitate interactions and decision makings based on interactions with our users, there are two types of harm that can be imposed against these groups of users. So the first one is going to be an allocation harm, which is most commonly the credit card approval or denial use case. And so this is where we're either approving or denying a certain group of users based on their features in a statistically significantly higher amount or lower amount than a second group of users. So the second type of harm is quality of service harm. So even though there may not be an approve or deny mechanism, there may be a difference in the experience that the user is having with the AI system based on their features and their demographics. So as data scientists, when we're building these systems, it's really important for us to consider which group of individuals is going to be at risk for experiencing these types of harms while interacting with our systems. So I did use the phrase statistically significant, and that might have given you a hint that yes, there is a lot of math underlying these calculations, and we're already focused on solving the business problem as well as performing the math in building the most accurate model as possible. So to help us and to enable us to inject fairness into our systems is the FairLearn package. So the FairLearn package is a Python package. It's composed of not only the math that we need to identify unfairness and bias in our models, but it also has the math that we need to help mitigate the bias and unfairness in our models. And so to make things super user-friendly and also help bring in the business user into this process of making our models more fair, not only is there a mathematical package of libraries, but there's also a dashboard which lets us interact with our model and interact and deep dive into the features underlying our model. So the quickest way to get started with these concepts and these capabilities is to jump onto the Quick Start, and that's hosted on GitHub. So we're just going to go ahead and jump right in there. Now you can see that the Quick Start has it's quite user-friendly. This is a Python library, so you can do a quick pip install to get that FairLearn package available to you in your Python code. Now, the data set and the question that they're using for this example is, can we use the feature of sex to determine the probability of an individual making more or less than $50,000 a year? Now, we can look at the distribution of individuals within the underlying data set, and you will notice that there's probably about twice as many males as there is females. Now, the question is, does this impact the fairness of the prediction? And the answer is yes, it absolutely does. So we can go ahead and verify that using the metrics and the map within the package. But what I'd like to do is jump all the way down to the FairLearn dashboard, and we can go ahead and call out the sensitive features that we'd like to assess for unfairness and bias, and then kind of draw that correlation between how that feature impacts the model and how that feature modification impacts the results of that model. So we're going to go ahead and select sex. We have two subgroups. We have male and female. We can go ahead and measure that feature against accuracy, precision, balance accuracy, or recall of the model. And we can validate that, yes, we have a statistically significant disparity in the model performance for males versus females, where we have this underprediction of 14% of males that are falsely being predicted as making over $50,000 a year, whereas we have underprediction of only 6% for females. So this leads to a disparity of about 16%. So now that we've identified the bias within our module, like what tools do we have to go about addressing this? And the FairLearn math libraries also provide a mitigator function. We can go ahead and pass in that sensitive feature of sex. And what it'll do is it'll actually adjust the selection rate of what amount of individual data we pull into our model. So you can see here that it's recommending that we take that 15% from female and 17% from males. And it'll actually give us the tools to evaluate the original model against the mitigated model. So what type of difference is there in making that change to the selection rates? And we can see that we are going from a disparity rate of almost 15% down to a disparity rate of under 2%. And the change in the accuracy of our model is only about 2%. So we go from 84% here to 82% here. So within the Quick Start, you can also reference the user guide, the API reference, as well as example notebooks. And you can see that they have also included sample data sets along with the source code. So you can go ahead and very easily and fairly quickly download the zip files and get started on your own. So I encourage you to jump on in there and spend a little time when you have some downtime. Now let's talk about InterpretML. Now, why is it important for us to have transparency in our machine learning modules? Transparency can help us identify overfitting, bugs in our data preprocessing, and also identify and detect potential bias. Now, this level of transparency also helps us to explain what data is affecting the model and establish trust with our business users. Now, some of us are building models for high-risk situations or in an environment where we have legal requirements to trace data to the prediction outcome. And transparency is a tool set that we need to start adding in, so if we aren't already, so that we can go ahead and satisfy those requirements. Now, when we look at interpretability, we identified glass box models as well as black box explainers. So glass box models will perform a mathematical regression against the data set so that we can do a trace from the feature item to the outcome of the model. Black box explainers, on the other hand, assume that we only have access to the inputs and the outputs of the module, and we don't have access to the algorithms being used to build it. So they provide an approximate explainability, whereas the glass box models provide an exact explainability where you can absolutely reproduce the results. Now, InterpretML is an open source package developed by Microsoft, and very similarly to the FairLearn package, there's going to be a library containing the math behind the features and a dashboard where not only the data scientists, but also the business users can go ahead and leverage the libraries. So part of the InterpretML package is going to be the classical text explainer, the unified information explainer, and the introspective rationale explainer. And the libraries are built to be used alongside the scikit-learn libraries. So developers who are in Python and using that library can go ahead and continue using the data frames and the arrays that they're currently using, and they don't have to do additional transformations to their data sets. Here I'm looking at the adult data set, and this is comprised of the features that we're using to possibly predict income. So these are going to be my features here. Now we can go ahead and reference the scikit-learn libraries and then go ahead and pass the data set into a black box model. Now I'm going to go ahead and skip down to our explainers, and we're able to see that capital gain is showing up as the feature that affects sensitivity. And you can see that there's, in this model in particular, there's a direct correlation between the feature capital gain and the prediction for income. Now, just like the FairLearn libraries, you can go ahead and access the dashboard for this data set, and we have the overview, data performance, and global sensitivity that we can look at in additional detail here. We can look at the distribution of our training data set, and we were looking at capital gain. And we can see the values there. We can look at performance again for the model. And then we can go ahead and skip over to our global summary and our sensitivity. So you can see how a business user who isn't particularly the person building the code in the notebook can have access to the dashboard and can do their own navigation and inquiry into the model and provide that extra sanity check against what the data scientist has built and possibly establish a more deeper understanding of the data and the data model. So if you're not already using a tool to add visibility into your data model, then this is something that's available that you can introduce to your data scientists. And now I'd like to talk to you a little bit about SmartNoise. SmartNoise was previously known as WhiteNoise and has very recently been renamed. The package is actually the creation of a public group called OpenDP, and it's an entire differential privacy system. So the intent of the system is to help secure personally identifiable information as well as prevent database reconstruction attacks. So the system provides the check and balances to people accessing data. So what it does is it controls the data and throttles the amount of data accessible to individual users. You can go ahead and inject noise into the data so that you can minimize the impact of the anonymization against the results of your data. So it really allows the researcher to adjust their levels of control, and it also provides some reporting and transparency into the data that's used into the model building process, so that again we can take that step back and we can report how our results and predictions are being affected by the underlying data. So this is kind of an overall diagram of how the system works. You have a group of users, they're assigned a budget, and when they query, they'll go ahead and first get authenticated to their budget store within the privacy module, and the check occurs to see how much of their quota they've used as far as data that they're querying and selecting. And based on that credential check, they can go ahead and get their results back. And if you want to simplify how that process works, say there's 100 records in a data set, or let's say 1,000 records in a data set, you would give a user the ability to query maybe 5 to 10%, and anything more than that, they would have to request additional approval so that they wouldn't be able to query the entire data set. And that would be controlled by the budget store. So fun fact about OpenDP. So OpenDP is an open source collaboration, and it started as a joint venture between Microsoft and Harvard's Privacy Tools project. And the community is actually made up of academia as well as people in industry. So I strongly encourage you to take a quick look at the OpenDP site and either join a mailing list or send a note over. I strongly feel that as data professionals, it's all of our responsibility to maintain stewardship over our data, and that includes machine learning data. So they have a lot of fun information going on, and it's a great time to get involved early on in some of these data stewardship projects, because privacy is really privacy and responsible ML. It's really all of our responsibilities. So the system is going to be made up of both core and system components. The core components are going to be the math behind the system. So the libraries for the statistical evaluations are going to be in there, as well as the Rust reference runtime and the Python language bindings. Now, the system components are going to be the wrappers that help you to pass queries, intercept and pass queries to the data sources. There's also going to be the functionality for the REST endpoints in there, and there's going to be some support for some of the tests that you'll be running for privacy, accuracy, and bias. Now, the third component of the system is the data access component, and this is pretty neat. This is how the users can embed differential privacy into their standard work. And what we see in how people use data currently is maybe we'll query a database and either export the results or query the database via a report. And most of what we're doing is with open select statements. So select fields A, B, C from table A, and left join fields E, F, G from table B. Now, what the data access component does is it'll go ahead and take the query and extract the metadata from the query, checks the query to make sure that it meets the requirements for data privacy. It'll actually modify the query to enforce differential privacy is met, and then it'll go ahead and send that query over to the database and perform the execution. So for anybody who's taking compiler class, we know that there is parsing involved in that, and you would think that you would need a whole nother set of processes to do that, and that's what those components were that we were looking at, those wrapper components. And we'll go ahead and take a look at the implementation, and we'll see that, and this is actually a call here where we're going to go ahead and pass the age date field, which is the field storing date, which is definitely a PII field, and we can go ahead and pass over an epsilon value to determine how private we want that data. So larger epsilon means less privacy, so we have for the mean higher epsilon, and for the variance a lower epsilon. And then we can go ahead and get a response back, and we can see our epsilon is 1.0. So what's happening is we are querying using our budget to return a value that is returning a differentially private data set. So the final component is going to be the evaluator, and the evaluator helps us to look at the result set and see if our tests pass the differential privacy conditions, and what the upper and lower bounds were for our data sets as far as reliability and our confidence of the data. And there is some distribution analysis to see if the queries are balanced. So you may be wondering, how hard is it to get your data scientists to start integrating differential privacy practices into their coding projects? And it's really not that hard at all. You can see that I'm actually referencing the WhiteNoise libraries and 4 lines of code here. I'm pulling the metadata and the SQL libraries as well as the pandas libraries. You can see the pandas reader and the private reader are the wrappers within the WhiteNoise package that let me go ahead and intercept and inject differential privacy into my SQL. So this first Python bit opens up my training data set. I can go ahead and pull my metadata from my YAML file, and then I'm forming a query. So this is select P-class average fair count star from Titanic training. And this is, of course, the Titanic training set that's very commonly used by the data science community. I'm going to go ahead and instantiate the pandas reader as well as the private reader. And with these 2 lines of code, I can go ahead and reference the private reader and pass the query. So you can see that once there's that instantiation of the new reader, the data scientists can go ahead and continue to form queries as they're used to, and they're passing that query to a new reader, and that's basically it. There's no additional lines and lines and lines of code for them to start inserting differential privacy into their code. And what this private reader is going to do is it will go ahead and pass that query over to the libraries within the system, and the libraries within the system will do the parsing of the query and the evaluation of the query, as well as making sure that the results passed back are differentially private. And that's very transparent to the user who's doing the same thing that they've been doing as far as creating a query and passing the query to a reader. So I do have a little bit of code that I can share with you. What I've gone ahead and done is I have installed the WhiteNoise libraries, and I have a Jupyter Notebook available. So I've gone ahead and installed the libraries. We've got the NumPy math and statistics libraries as well. And I am evaluating the California demographics data set. So this has 1,000 records and has the variables age, sex, education, race, income, and married. So this notebook is part of the files that are available on GitHub. So I encourage you to go in and play around when you have an opportunity. What I'd like to show you, though, is this result set after applying differential privacy algorithms to the initial data set. So you can see true value is green here, and then we have the geometric transformation here, and we have the Laplace transformation here in yellow. So the question when applying these differential privacy algorithms to data is always, well, how much does that affect the underlying analysis, and how much does that skew the predictions if you're applying transformations to the underlying data. So with this algorithm, you can see that in most of the ranges, the variance is going to be very, very minimal. So we're looking at income, and at the more populated income ranges, the variance is probably the least noticeable. And then when you get into these income ranges where there isn't as much of a population, that's where you see the algorithm does tend to skew based on it trying to fit that data set under the curve, right? And so we can see the histogram of sex is very, very similar, so we don't notice that much of a differentiation. And then history of education. There seems to be some spikes here. I'd like to encourage you to continue on your journey learning about responsible ML. There's great resources on the Microsoft site via machine learning responsible ML, and there's quite a bit of code and sample projects available in GitHub, and these projects are maintained by the OpenDP as well as Microsoft researchers. So there's a ton of samples, and the code is very well integrated into the functionality of the new releases. So definitely want to get digging into that. I'd also like to say thanks to Microsoft for supporting Data Platform Geeks and SQL Server Geeks. And Data Platform Summit would like to say thank you. So don't forget, there's 3 ways to win prizes. You can go ahead and post your selfie with the hashtag DPS 2020, give session and conference feedback, visit our sponsors and exhibitors, and follow us on Twitter at The Data Geeks or at Data AI Summit. So thank you, and I'm looking forward to seeing you in Q&A.